Yes, very good morning, dear students. Welcome back to online physics class, grade 10. Yes, dear students, I think today we have foundation classes there, and just I sent it to you one CBSE video also. I think last class some of the students are not seeing that video, and after that I will discuss this. I will start this foundation also because we all in this foundation we want to complete some syllabus. Yes, dear students, today I am going to discuss about already we know about angle of deviation, and now today I am going to discuss about calculation of angle of deviation. I think this thing I discussed already in CBSE itself, but again I am discussing here calculation of angle of deviation, calculation of angle of deviation, and for single plane mirror, for single single plane mirror, and next one is calculate calculation of calculation of angle of deviation, calculation of angle of deviation. It means the deviation produced by the deviation produced by n reflections, the deviation produced by n reflections from two plane mirrors. It is only one single plane mirror here. From two plane mirrors inclined at angle theta. Next one I'm going to discuss about diverging and converging light rays. Converging light rays. And the next one is types of images. And next one, image formation. So due to plane. Today everything I want to discuss about concepts only. And next class next class in the foundation next class foundation class I will discuss problems on this plane mirror, right? See, first one is about calculation of angle of deviation. Calculation of angle of deviation. Angle of deviation. So how we can calculate angle of deviation? It is for single plane mirror, dear students. For you can write SPM. It means single plane mirror. Just you can write totally. See, for example, I'm taking one plane mirror. This thing I already know. I think in CBS itself I discussed this. But actually, it is a foundation concept. In CBS, it is not there. So I'm taking a plane mirror. So I'm taking incident light ray. So it is incident on a plane mirror. So it means a point of incidence. Point of incidence is nothing but what? The point at which the incident light ray strikes the mirror is known as the point of incidence. Next, incident light ray is nothing but the ray which strikes the mirror is known as the incident light ray. For example, just already I told, whatever incident light is incident on mirror, 100% of light it is not observed. 100% of light is not observed, and 100% of light is not reflected. So for that only some part of light, some 1% of light, 1% of light is transmitted through the plane mirror. 1% of light is transmitted through the plane mirror. So then what happens? Some part of light will be reflected, right? So some part of light will be transmitted, means it we call it as emergent light ray, and some part of light will be reflected, and some part of light will be observed this plane surface. This is a case, this is a thing, it will happen whatever the light ray is incident on a plane mirror. Next one is, it is a normal. What is this? It is a normal. So normal means what? The perpendicular drawn at a point of incidence is known as the normal. So it is what? Angle of incidence. Angle between incident light ray with the normal is known as the angle of incidence. So it is what? Angle between the reflected light ray with the normal is called angle of reflection. See here, what is the angle of deviation? Right here, angle of deviation is nothing but what means the angle at which it deviates from its original path. So actually it is a deviated ray. I mean, it is of course reflected ray from its original path, or else the angle between the reflected light ray with the emergent ray, we call it also angle of deviation. It is a delta, right, dear students? And here I want to introduce two new terms. One is glancing angle of incidence. Glancing angle of incidence. Glancing angle of incidence and glancing angle of reflection. GAFR. GAFR. Glancing angle of reflection. So that I will discuss after completing angle of deviation. See here, now here I want to calculate angle of deviation. See, it is just in it is a one line. So I here three angles is there, I or delta. So whenever three vectors or three angles are lies in a one line, then sum of three angles should be equal to 180 degrees, right? Yes. So using that technique, I will write. So I plus r plus delta equal to 180 degrees, and delta equal to 180 degrees minus I minus r. So this is about angle of deviation for single plane mirror. So this is angle of deviation. It is angle of deviation, angle of deviation for a single plane mirror, single plane mirror, right? Yes. Now before that I told what is the meaning of glancing angle of incidence and glancing angle of reflection. So see, here I am taking again, first I want to discuss glancing angle of incidence. You write totally G suffix I, it is a glancing angle of incidence. See dear students, again I am taking a mirror. So it is incident light ray, it is a normal, and it is a reflected light ray. See what happens, see, it is actually what angle of incidence, it is actually what angle of reflection. See dear students, it is actually total 90 degrees, right? Then it is how much? 90 minus I, understand? It is total is 90, but it is how much? 90 minus I, and it is a total how much? 90, again it is how much? 90 minus r. So here glancing angle of incidence is nothing but the angle made by the angle made by the angle made by the incident light ray, incident light ray with the mirror, incident light ray with the mirror is known as the glancing angle of incidence, is known as the glancing angle of incidence. So it is denoted by GI, understand? And GI equal to 90 minus I, GI equal to 90 minus I. So next one, dear students, next one is a glancing angle of reflection. Next one is what? Glancing angle of, if I will write short terms, means just you can in your notebook you can write full terms, full glancing angle of reflection. It is nothing but G suffix R. See from the diagram, from above diagram, from diagram, it is defined as the angle between, or the angle made by the reflected light ray with the mirror is known as the glancing angle of reflection, glancing angle of reflection, and it is denoted by It is denoted by GR, and GR equal to 90 minus or dear students, right? So this is about glancing angle of incidence and glancing angle of reflection and angle of deviation. So this is over already. So next I am going to discuss the calculation of angle of deviation. So for the deviation produced by n reflections from two plane mirrors inclined some angle theta. See, second case is, second one is calculation of, it is a direct formula, calculation of delta. Delta means what? Angle of deviation. It means the deviation, it is not single plane mirror, the deviation produced by n reflections, the deviation produced by n reflections from two plane mirrors inclined at angle theta, right? So this I want to discuss here. It is a direct formula. So that is, the formula is a delta equal the deviation produced by, just you can write again here, the deviation produced by n reflections from two plane mirrors inclined at angle theta is given by delta equal to n into 180 minus theta. It is a direct formula. Again you can write here, dear students, the deviation produced by n reflections from two plane mirrors inclined at angle theta is given by delta equal to n into 180 minus theta, where, so where delta is angle of deviation, delta is angle of deviation, and n is number of reflections, and n is number of reflections, and theta is angle between two mirrors, angle between two mirrors. So now for example, for example, if n equal to 2, if n equal to 2, it means where n is even, where n is even, so then delta from delta equal to n into 180 minus theta, then delta equal to n means what, 2 into 180 minus theta, then delta equal to 360 minus 2 theta. So like this we can calculate it depending upon number of reflections. This is about the angle of deviation for single plane mirror, glancing angle of incidence, glancing angle of reflection, and calculation of angle of deviation for the deviation produced by n reflections from two plane mirrors inclined at angle theta is